So assignment number 4, question 7, starts out by saying the angle of elevation from the top of a 45-foot building to the top of a nearby tower. So here's the building, and if I'm looking straight across, I have an angle of elevation of 15 degrees, 20 minutes. So that means it's going to be this angle of elevation. 15 degrees, 20 minutes is my line of sight. Elevation always starts horizontal and goes up. Okay. Over here's what I'm looking to calculate, the height of the tower. But I just drew a triangle right now, and we'll see what's going on. From the base of the building, so now I'm looking at the base of the building and I'm going straight across. I have the angle of elevation to the top of the tower, which would be this guy going up to there. That angle of elevation is 29 degrees and 30 minutes. So I drew this is all of the information I'm given, and I need to calculate the height of the tower. Well, I do know this is 45. And if that's 45, that means this is 45. So really, if I could find this X, I'd be in great shape. This X is what I'm kind of looking for, because then I would add that to 45 and be done. So if I look at my two triangles, my top one goes something like this. I go across, I have X, which I don't know, and I have 15 degrees, 20 minutes. If I take a look at my second triangle, it's a little steeper, it goes up. I have something that looks like this, 29 degrees and 30 minutes. And I know this guy is going to be 45 plus X. So there are my two triangles. I know they're both right triangles. This one is X. I don't know that, and I don't know this base. Down here, I have that as 45 plus X. But I do know one thing. The base of this upper triangle and the base of this triangle are going to be the same. So if I call this B and this B as well, I can come up with two equations. Now, I do have an equation, but I have two unknowns, X and B. I have an equation that's going to also include X and B. My first equation, tangent of 15 degrees, 20 minutes equals X over B. Second equation, tangent of 29 degrees, 30 minutes equals opposite, 45 plus X over B. Okay, so here's what I'm going to do. I'm going to say I'm going to bring the B and I'm going to make this look something like B equals X over tangent of 15 degrees, 20 minutes. Same thing here. I'm going to say B equals 45 plus X over 29 degrees, 30 minutes. Now this is equal to B and this is equal to B, then those two have to be equal to each other. And what I'm going to end up with is something that looks like X over tangent of 15 degrees, 20 minutes equals 45 plus X over 29 degrees, 30 minutes. And as you can see, I'm now down to one equation, one variable X. And as I go through and solve for this X, I know I'm going to take it eventually and add it to 45 to get the height of the antenna. So I looked at the two triangles, and you were asking for help on word problems. I rewrote them. Once I set all this up, and of course I needed to understand the term angle of elevation, I came up with two triangles, but so much was missing, except I called this base and this base, and I'm saying, okay, I can come up with an equation with two unknowns and another equation with two unknowns. And now I get down to here. I can find these values if I want, and it's just going back to your college algebra class to solve for X. So that was the first one you had a question on. The second one was back in chapter 2. And, you were talking about getting these set up. So I'm going to do number 9 from that chapter 2 test. Okay, I remember that I had some formulas. S equaled theta R, and that was for my arc length. So I need to make sure I know what I'm talking about before I start. If there's R and, I have a theta in here, and that's R. If I want to know what this is, my arc length, that's S. Okay, so I had that from chapter 2. I had another one that was for area of a sector. And then we had a couple of other ones after that. So I needed to make sure I understood the equations before I took a look at this. But I want to set this up. A pendulum. If I have a pendulum that hangs down, sort of something like that, it is 12.1 inches. So if I would take that pendulum and spin it all around, I'm thinking, yeah, I'd have a circle. So this pendulum right here is actually going to equal the radius of the circle. Now this guy swings that way, 5 degrees, 37 minutes, and it swings this way, 5 degrees, 37 minutes. Well, that's going to be a total of 10 degrees, 74 minutes, but 60 of those is going to become a degree. So 11 degrees, 14 minutes. Now my formula, because I want to know what's the length of the arc the end swings. I want to know that arc, and that's the same as my arc length. So I need to calculate S, and that's going to be theta R. Well, this is tempting because it says the angle measures 11.7, but I can't really use that. What I need to use instead is I need to take 11 degrees, 14 minutes, and I need to convert that into radians. And the way we did that, we had radians, we had degrees, we had pi, 180, and you'd have to do the conversion. So that's going to end up being my new theta. So theta is going to equal something new. Once I calculate that, I'm going to take it and put it up here for theta, and then multiply it by 12.1, because I'm using this formula. I hope that helps. Again, this is number 9 from the chapter 2 test. And the other one I did was number 7 from assignment number 4.